So we've just talked about how supplying energy to a system increases the temperature depending on the specific heat capacity, depending on how much temperature is changing by and depending on the mass of the substance. We can also change the state if we continue to heat it. For example, if I do water, starting off at 0 degrees, so it's solid water, we call ice. What will happen if I heat it up? The temperature will increase. Temperature will increase up to a certain point. The particles are moving faster, they're getting more kinetic energy, they're getting more internal energy, they're increasing thermal energy, so they're getting hotter. But at a point where the bonds start to break, the temperature doesn't increase anymore. The temperature plateaus, it stays flat, it levels. At this point it is changing state. Change of state, in this case it's from ice to water, so it's melting. And once it's finished melting, the temperature increases again. Temperature increases again, and temperature increases up until a point. So this liquid temperature is increasing up until a point where it starts to boil. When it boils, it's changing state, so the temperature stays flat. Change of state, boiling. And once it's finished boiling, the temperature will go off to increase again, and there's no more states for it to change into, so just temperature will keep rising and rising and rising. And when we've got these changes of state, we can use an equation links energy, mass, and specific latent heat. So energy, again, in joules, equals mass times specific latent heat. And specific latent heat is measured in joules per kilos. Joules per kilos. If we've got more mass of substance, it's going to take more energy to change the state from a solid to a liquid or a liquid to a gas. And if we've got a greater specific latent heat, it's going to take more energy. For example, water has got two specific latent heats. It's got specific latent heat of vaporization, and vaporization is between a liquid and a gas, or a gas and a liquid, so it's double-ended. We use this number, and this number is 2,260,000 joules per kilogram. Really big number, don't need to remember it. That's specific latent heat of vaporization for water, for a liquid to a gas, or a gas condensing to a liquid. The specific latent heat of fusion, fusion means between a solid to a liquid or a liquid to a solid, is much less. It's much less. For example, it could be 200,000 joules per kilogram. And again, you don't need to remember this number. What you do need to be able to do, though, you need to be able to recognise that vaporization is linked to the state change between liquid and gases and liquid. You need to recognise that fusion is for solids to liquids, liquids to solids. You do need to be able to explain this graph. You need to explain that temperature is increasing due to specific heat capacity. You need to be able to explain temperature is not changing because it's going through a state change, going through specific latent heat of fusion in this case. So let's add this on too. Once it's finished melting, temperature will increase again due to applying more energy, specific heat capacity, increased temperature. Then when the temperature is flat again, it's changing state, so it's boiling, so that's vaporization. Then once it's finished boiling, if we keep supplying energy, temperature goes up and up and up and up. If we were to cool it down, temperature would decrease due to particles moving less quickly, less kinetic energy, less internal energy, less thermal energy. It would then condense, going through the latent heat of vaporization. Once it's all condensed, the temperature would keep decreasing because we're removing energy, particles are moving less quickly, less kinetic energy, less internal energy, less thermal energy. Eventually that liquid would start to freeze, so it would go through the latent heat of fusion, where it's changing state into a solid. Again, temperature doesn't change. Once it's finished freezing, the temperature would then start decreasing again because particles are moving more slowly, less kinetic energy, less internal energy, less thermal energy, and then it would keep decreasing because there's no more state for it to change into.